Dear children, now we will come to the exact self-inductance solenoid, the meaning of self-inductance. Once again, I will remind you, students, that never say long solenoid. You have seen that a solenoid is a number of tones whose length, of which the length is much, much greater than the radius. So don't say long solenoid. It is not a good English or a good physics. So now, field is 4 pi Ni. You have seen that in the solenoid, N is number of turns per centimeter. Flux, field into area. The field into area, 4 pi Nia, unit is Weber. You know this. Unit of field is in electrostatic, Newton per coulomb. In magnetic, dyne per, instead of coulomb, per magnetic pole, unit pole. Flux linkage is 4 pi NAI. So let us put the symbol phi. Induced EMF is, minus d phi dt. And minus is not a mathematical thing. Minus in physics means the induced EMF is opposite to the voltage that make it to have a current. 4 pi Na di dt. Induced EMF E is minus L di dt. So L is a constant, 4 pi Na. Now di dt is the rate of change of current with respect to time. The more the rate of change, the more will be the induced EMF, the less will be the less. So L is constant, known as self-inductance. Why we call it self-inductance? See, we call it self-inductance because the voltage is coming from the coil itself. I just apply the current and the induced EMF come from the coil itself. So that is self-inductance, not like mutual. See, this is mutual. The mutual means what? I send a current in this primary and this is a magnetic material. Say steel will be best. So I send it here. So what will happen when I on this, there will be di dt from 0 to 2 ampere. So di dt will be there. And at the same time, if you look here, you will see the voltage either to the left or right. And these are known as mutual inductance, not like self. This is the primary, this is secondary. Nothing is there on the secondary, only change is in the primary, and this is mutually connected, so mutual inductance. So now you understand this, I1 changing in the primary, so we could see I2 in the secondary. No voltage source at all in the secondary. Due to this, we have a mutual inductance. Then we have shown that the impedance of a coil, long time back I have shown you, when B is B naught sine omega t, that means the voltage is alternating, is omega L ohms. I have shown you also how we get ohms. It is resemble the ohms, the main ohms in Ohm's law, the first one. So the omega is twice pi by t. T is the time period of a sine wave. So now twice pi 1 by t, twice pi f. Now if the frequency is 50, then it will be 2 pi into 50, 100 pi. So this, you understand this. So this is the impedance. Now, beautiful objective question I'll give you. So you give me the answer. The answer for this. See, this is the solenoid. This and this are same. This is air. This is a bulb. Say 20 watts, and this is 200 volts, 50 hertz. This bulb also is capable of holding 200 volts. So this is one. And here also we have got the same solenoid. The only difference is this is air and this is the steel. I think you remember the day when I introduced the steel here. So that steel won't be there. I got different wire of steel. I put them inside. I insert them here. So the bulb A is same as this. Voltage is same. frequency is same. Now, please tell me which bulb will glow brighter, the figure 1 bulb or the figure 2 bulb. And then I have also told you that the inductance is the field is 4 pi Ni in air, and the field when this is mu, when the permeability of this is mu, the field is no longer 4 pi Ni. Now mu is no longer 1, mu will be some mu, and that mu is greater than 1. So tell me which bulb will glow, whether the figure 1 bulb or the figure 2 bulb. I will keep you 3-4 days time. It is good also so that I can remind you. In the tomorrow, day after tomorrow, I'll go to a different topic. Thank you.